We're at the Upper Bonnington power plant, halfway between Calscar and Nelson in British Columbia. The plant has 6 generators, 4 that were commissioned in the early 1900s, and 2 newer units that were installed in 1939. Being over 100 years old, these 4 older units are most certainly end of life. In spite of our best maintenance efforts, they continue to have failures. The biggest areas of concern are reliability. Our equipment is old, it's obsolete, spare parts are hard to find, and it's hard to get technical assistance from the manufacturers if they don't exist anymore. The second area of concern is environmental. The older units use a high volume of oil in old tanks. Newer systems use much less oil and have modern spill containment. And finally, and most importantly, is safety. Because of the nature of the operation, the employees have to work close to moving parts and energized equipment. This puts them at a higher risk of having an accident or an injury. Fortis BC owns 15 generating units on the Kootenay River, 11 including the 2 newer units here at Upper Bonnington. They're controlled and monitored by our system control center, and they're started and stopped remotely with the push of a button by an off-site system operator. The old units here at Upper Bonnington all have to be manually started and stopped, and the process literally is a 50-step checklist that takes 3 tradesmen. We need to initiate excitation voltage by starting our water wheel exciter and visually confirming that the unit is spinning. Next, we need to open the governor oil valve and confirm flow, then start the bearing oil pumps, and then open the cooling water valve. Once cooling water is flowing, 2 tradesmen are required to manually turn the hand wheel to free the governor arm. They then manually open the wicket gates to set the unit speed to approximately 179 RPM. This unit has to be manually synchronized online, which is unlike our remotely controlled units. The proper voltages and power factors need to be loaded onto the unit to achieve the desired megawatt output as directed from our system control center. As I said before, the equipment involved is old and sometimes unresponsive. This only adds to the risk when operating. For example, the protection and control system is mainly vintage electromechanical relays. Their age gives rise to a number of operational issues, including the unavailability of spare parts and lack of in-house expertise. The exciter and governor systems are original and are very unreliable. Parts are no longer manufactured, so maintenance requires either removing parts from other older equipment or we just have to custom manufacture it. Also, these governors cannot initiate a unit trip, so the only way to stop a unit is to manually close the wicket gates and apply the brakes. If that doesn't work, we have to drop our head gates while the unit's running. This is a very dangerous procedure and really puts our employees at risk. If you were to look inside these older units, you'd see that the internal components are very heavily corroded and clearly showing their age. This has a direct impact on our ability to control them. The 4 unit transformers are from a variety of manufacturers and are all completely different in design and age, the oldest being 80 plus years old. This older transformer is a 3 separate single-phase design that is water cooled, and with its failure history, replacement has been recommended. It's obvious that the systems and equipment at the Upper Bonnington old plant are end of life. In my opinion, the recent failures prove that the units are unreliable and that they're going to continue to expose our workers to safety hazards, which I believe is definitely avoidable.